Okay, guys, so at this point you should be finished with your test. You should have stapled it and turned it into my inbox or to Mr. Hansen. And now we're going to move on to linear inequalities. We've been looking at systems of equations. Now we're going to look at linear inequalities and systems of linear inequalities. And to start, what we're going to do is we're going to solve for the following equations and or inequalities. Now, of course, to solve for x here, we need to get all the variables on one side. And to do that, you have to subtract 3x. And so you would get 2x over here minus 4 equals 12. And then we need to get all the numbers on one side, all the constants. So this would equal 16 equals 2x. X equals 8. Okay. Number 2, same thing. We need to get all the variables on one side. And all the numbers on one side. Q equals -3. All right. Now let's look at inequalities. You should remember these from last year because you spent a lot of time doing this in pre-algebra. But we're going to review how to solve for these. What you're going to do is you're going to treat the inequality sign as an equal sign and then solve for W. So whatever you did over here for your equal sign, you're going to do the same for number 3. Alright, so I'm going to get all my variables on one side, which now gives me 2w minus 4 is greater than 12. Then I need to get all the numbers on one side, which will give me 2w is greater than 16. Divide by 2, w is greater than 8. Number 4, same thing. We need to get all the variables on one side. So that would give me 5r plus 10 is less than -5. Now I'm going to get all the numbers on one side, and I have 5r is less than -15. Divide by 5, and you get r is less than -3. In lesson 2.1, you use graphic and symbolic methods to analyze a system of equations. The problem conditions can be expressed as two equations relating security costs and the number of days for the business contract. Now, this is when we first started graphing linear equations, and we looked at two security systems. I think it was fail-safe and safe lock. Alright, and then what we found was that the coordinates of the intersection points of the graph satisfied both equations in the system. This point is the solution. Of the system. The cost for the two security companies, area system of linear equations, right below where equations represented superlocks and fail-safe. I'm going to go ahead and write those for you because I'm sure you don't remember. The cost equals $3,975 plus $6 per day, and that was for the Safe Lock company. And then the cost for fail-safe was $995 plus $17.95 per day, and that was for fail-safe. Now, in previous units, we learned that some methods to solve linear systems to find the number of days for which the costs are the same for both companies. We set them equal to each other, and then we solved for the variable. So what this means, number one, determine how the solution is determined, or describe, is we just solved for D, right? For D. And we use substitution, remember, to set the equations equal to each other. Number two, what is the meaning of 249 is approximately D? That means the cost is the same for both companies, on about the 249th day. How can the solution to this system help you answer the following question? For what number of days will super locks cost less than fail-safe? Any contract greater than approximately 250 days. All right. So now we're going to determine the solution to the following inequality. We set this up here and solve it just like we solve an equation. All right, we're going to get our variables on the same side, and to do that we need to subtract 6D, and once you do that you get $11.95 times D, and then we need to get our constants all on the same side, and to do that you would subtract 995 and you would get $2,980 is less than $11.95. Then we divide by $11.95 and you would get $249.37 is less than D. Now, how does this solution to number 4 compare to 249 to the in number 4? How does that compare? Well, this is the approximate answer, and now we have a solution that is more specific, which means that any day greater than about 250, safe lock cost is less than fail safe. Okay, I'm sorry, it's super locks. So you would write it is more specific, is more accurate. And instead of using an equal sign, we're using an inequality. Number 6. Why do you think the equation was changed to an inequality? What was the benefit of changing the equation to an inequality? Go ahead and do number 6 yourself, and then discuss that answer with a peer buddy. All right, let's look at part 2. Solve the following inequalities and graph their solutions on a number line. All right, so for number 1, we're going to solve for x, and to do that, we need to get all the constants, which are numbers, on one side. And to do that, we would subtract 17, and you would get 30. Then from here, you solve for x, and x equals 10. Now, to draw this on a number line, you don't have to make a fancy number line, but always label 0, and then 10 is here. Now remember, when you have a greater than or less than sign, it's an open circle because we're not including the number in the solution. And we're going to read the inequality going from left to right. X is less than 10. So what you're going to do is shade in everything less than 10. Okay? All right, let's look at number 2. And number 2 is important because there's a rule that you have to remember. All right, 18 is less than negative 4x plus 2. So what we need to do is subtract 2 from both sides to get 16 is less than negative 4x. And then from here we have to divide by negative. Now if you remember from last year, what happens when we're solving for inequalities and you have to divide by negative, you got to flip the sign. And so now we have x is less than negative 4. Now you're going to draw your graph, find 0, or I'm not find, but draw 0. Negative 4 will be here. And I need to make sure I'm reading my graph my inequality correctly. X is less than negative 4, so that's going to be an open circle. And then I'm going to shade in everything less than negative 4.